Welcome back. All right, in this video, we are going to go a little deeper into average rate of change, instantaneous rate of change, and how they relate to the tangent line. Okay, average rate of change, basically just think of your literal Algebra I slope formula. All it is a fancy way of writing y2 minus y1 over x2 minus x1. That is all. This will give you the slope of the secant line between 2 points. So let's say we have a circle, and let's say we wanted to get the slope between these 2 points. That is basically what we would be doing, something like that. Now, once we get to calculus, we're really interested in the instantaneous rate of change, or the rate of change at a specific point. So in order to find that, we have to take the derivative. That is going to give us the instantaneous rate of change, or the slope at a certain point. Now, how does all of this relate to the tangent line? So let's just take a look at a very quick example. Let's say we have a simple cubic function, something like that. We may want to get the slope specifically at this point right here. So in order to do that, again, I would take the derivative, find the slope at this point, and then I could draw my tangent line, which again touches right at that point. So looking at this tangent line formula, some of you may notice that this looks a lot like point slope formula. Again, going back to our classic Algebra I formulas, what is point slope formula? Well, it's y minus y1 equals m times x minus x1. All this tangent line formula is a fancy way of writing point slope formula. So all you would have to do is find this exact point, x comma y, and then you would take the derivative, plug in that x value to get, again, your slope, your m value at that exact point. Let's go through an example to make sure all of that makes sense. Okay, so let's look at a simple quadratic formula, just x squared. Let me try and draw it here for you. I'm going to exaggerate it a little bit. Let's say it's something like that. Okay, so first thing let's talk about is the average rate of change. Let's say we wanted to look at the average rate of change between x equals 1 and x equals 3. Let's say it's maybe somewhere here. So I'm just going to write these full points. To get the other coordinates, the y values, I'm just going to take my x values and plug them in here. So when x equals 1, 1 squared is 1. So that point is just going to be 1 comma 1. When x is 3, 3 squared is 9. So this point is going to be 3 comma 9. Now, nothing fancy. I'm just going to use y2 minus y1 over x2 minus x1. So I'm going to get 9 minus 1 over 3 minus 1, which gives me 8 over 2, which gives me 4. So that tells me the slope between these 2 points, like that, is going to be 4. All right, now let's look at the instantaneous rate of change when x equals 2. So let's say that point is somewhere around here. To get the instantaneous rate of change, we have to take the derivative. I'm not going to go through in detail how to do that. In this example, all we're going to do is just use the power rule. So the derivative of x squared is right here. It's just 2x. Now we're going to plug in our x value, which is x equals 2. So plugging that in here, 2 times 2 just gives us 4. So that tells us the slope of the tangent line at this point is actually also 4. That doesn't always happen. That's just coincidence. So the slope of the secant line usually actually will not equal the slope of the tangent line. It can, but it definitely won't always be the case, so don't just assume those will always be the same. So now let's see if I can draw these. They're going to be so close together, but bear with me. So basically the line there kind of over to the right is going to be my tangent line. I'm going to write an S for secant and a T for tangent. There we go. Okay, so now let's get the actual equation of that line. So what you'll see here, again, this is basically, we're just going to use y minus y1 equals m times x minus x1, and we're going to get the equation of the tangent line. We already found our slope, right? Remember, our slope is just the instantaneous rate of change at x equals 2. So I'm going to plug that in first. Now my x1 and y1 are just the coordinates of this point. So I know my x value is 2. To get the y coordinate, I just have to plug it into my function rule. 2 squared is 4, so this point is going to be 2 comma 4. Now I'm going over here to point slope form, and I'm just plugging those values in. So my y1 is 4, my x1 is 2. So now the equation of this tangent line here would be y minus 4 equals 4 times x minus 2 in point slope form.